We touched on this earlier, but again, why is this multi-model database system a good idea? Here's some. This is not a complete list, but I like it. We touched on this, you and I did, but it's much easier to synchronize data. So if you have a multi-model database system that can do all these things, it's much easier to keep all of your data synchronized together. So with Orient, I mean, to us, there's really no difference technically between a document and, say, a vertex, the graph. So if you have transactions, if you have data pointing to each other, you don't have to worry about the synchronization happening because you can do all this inside a transaction. But advantage to this, additional advantages, you have standardized administration. So once you learn the ins and outs of backups, how to configure the system, how to deal with it, you don't have to learn 10 different ways of doing it. So that's nice. Usually it can reduce design complexity. It should, but maybe not always. But in general terms, it does reduce design complexity. Someone throw out to me why you think that is. Why would it reduce design complexity? And any ideas what I even mean by that?
I was going to say you can combine all the data seamlessly with one interface to different models.
Yeah, and that's true. So you might have 4 or 5 different applications that have different models, and if you can have a commonality there, even if it's just document and graph overlaid, that might reduce the overall design of the system instead of having to think, okay, this is relational, yeah, I gotta do that, and this is stored over in a caching system, okay, yeah, so I'll use that. Oh, this is big data, so how I approach that is different. I've designed it differently. Okay, I'm using Cassandra, so I have to worry about partition keys and how is it distributed. So overall, you can usually take these polyglot applications and reduce the complexity there. Sure.
So what's the trade-off? Centralizing everything. What's the impact on performance? And then how would you be able to avoid single point of failure?
Well, remember, it's not that you're saying we have just a single server or a single node. So actually you get better performance and better reliability. Why? Because you've combined all this together. It's not that you've just bolted it together. You've actually combined the models and how it's stored together, so it works the same way. Now, that polyglot solution, that's when you can get into those issues. If a node goes down and this one is dependent on your relational database, then what do you do? What's nice about these multi-model database systems, especially the ones that support a distributed architecture, which is pretty much almost all of them, is you get high consistency because of it. And so if this node here supports, let's say, Solr, Search, and Cassandra, and it's replicated to this node and replicated to this node and then replicated to a data center, you're going to have high availability, and the chance of failure is pretty low, right? So in actuality, you have fewer moving parts.
Okay, so the second question would be, what about performance?
Usually, you get better performance. Maybe not so if it's a true bolt-on solution.
Because it's encoding going on between this middle tier.
Yeah, like Cosmos DB would be a good example. Although they're really fast, they are, but that's an example of where something I'd be worried about having performance issues, because you have to have this translation layer, right? So if I'm writing some kind of API call that Cassandra and SQL, it has to translate that, and not just translate it as translating the SQL language. There are very specific ways that you use Cassandra, and ScyllaDB takes advantage of this. So under the hood, back on that Cosmos DB table storage, they have to implement really fast ways to do partitioning of data. I mean, they have to. Otherwise, you run into performance problems. But I think they might run into performance problems at times because of all these interfaces they have to support. But apparently, they do a good job of it. So if you have a single DBMS that can do all this. Obviously, you're going to have more consistent security, and it's easier to back up and restore and do all the typical database management you would expect, right? So that's a win. So this is interesting to me. Here are some examples. I'm just going to use OrientDB because I know it well, and it's kind of the epitome, and it's the one that started this multi-model craze. What's interesting in OrientDB is that if you think of a data set as a table, we call them classes, just like OO, object-oriented classes. So think of it as a class, but for now you can think of it as row, column type table. It's not implemented that way, but you can think of it like that. And a class is a collection of OrientDB records. Now those records, I'm almost done. She's like, wrap it up, hurry it up. I told you I'd be long-winded. We have, just throw me off now. Okay, a class holds OrientDB records. And again, I mentioned this earlier. Record can be a graph. It can be a vertex, it can be an edge, it can be a document, it can be pure binary data, all good. Each class has properties, just like in the OO world, programming world, you have a class and it's going to have attributes or it's going to have properties. We have the same thing. The coolest thing about OrientDB is this, to me. You can inherit from other classes as you define your schema, right? So you could have a base class that's car. You can derive from that and have specialization. It could be like Audi, it could be Toyota, what have you. And it supports multiple inheritance, and you can do polymorphic queries on it. So you can say, return all the cars, and even all the Toyotas and Hondas and all that can be returned to you as well. So that's kind of a cool thing. But very quickly, I was just going to show you this example. Pretend we have a vertex, and it's called hotels. This comes from our demo database, but just real quick. We have hotels, and it's derived from services, and services class is derived from locations, and locations is derived from the OrientDB V class, which makes this a vertex. That's what V means. Because of that, hotels itself is going to be a vertex. Had we not derived from V, it would just be a regular old record, or what most people refer to it as a document. It doesn't have to be, but if you want to think of it as a document, that's fine. Anyway, because of this, hotels is a graph vertex. We define 3 simple properties on this hotel. We have an ID, a type, and we're going to give it a name. I'm going to skip over the indices because it's not important right now. I just want to show you this. So using OrientDB SQL interface, I can do the usual select star from hotels. And even though hotels itself is a graph vertex, I'm treating it just like it's a document or a record, okay? And so this is just what gets returned from one of our studio products. But you can see the properties we talked about. So we have a type here, well, it's hotel, great. We have some identifier, and then we have a name, dunk, 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 dunk. It gets returned. And this is how we represent the connections to other vertices. So these are edges that they're showing up, and these are the record IDs I was talking about earlier. But that's not really important other than just to show you through SQL, even though hotels is not a document, it's a vertex, we can still use SQL in the same way to retrieve it. It could very easily have been a document, could very easily have been an edge, and we could query it in the same way. We can extend SQL, which we've done, and so we've added this out HasReview, which just means we're going to do an out traversal. If you don't know graph theory, that's fine. But we're just doing a traversal. It just means we're walking out one of the edges of the vertex. What this illustrates, though, is just that we have an interface, a SQL interface that we've extended, but by using it, you still can access the multiple models at the same time. It doesn't matter. It could be key value. You could use it. It could be document. You could use it. It could be any vertex or edge and still use it. Very quick, another example. If I want to insert a document, I can say insert into my document. This my document would be a class I defined earlier. And I do a set name and age. Conversely, vertex, look, create vertex, my vertex, but we still do this set name like that. This is a specialized keyword which tells the engine that it's a vertex and there will be edges applied to it at some point and so forth. It doesn't matter. What's significant is that we're showing you support of two different models, document and graph, in the same SQL interface. Any quick questions?
So I noticed that your query language, it introduces a new module, a new function, the traverse.
Yeah, we've had that for a long time, but yes.
Yeah, I'm just saying, apart from like SQL, the regular SQL,
Right.
it defaults to depth first, right?
Can be breadth first or depth first. Sure.
Transform to say.
Yes, and you can specify with the traversal the depth, how far you want to go. You can put that into a very complicated select upon select and into loops, and we have even variables you can use. You can get super complicated by doing that.
Switching from, I mean,
Depth first to breadth first?
those are parameters of depth, right? Can you switch to breadth first?
Yeah, you sure can. Yep. But this isn't the only way to access graph in OrientDB. We fully support Gremlin, we support Blueprints 2, which is the old Tinkerpop 2, and we support the latest Tinkerpops 3. So you can use Gremlin if you want to. You don't have to learn our SQL if you don't want to, but if you want to access it, you certainly can. So we're multi-model within multi-model of our own multi-model, so which is kind of cool. This is my last example. So this is just showing you the Java API. So let's say we have this thing called an O database session, which is what allows you to connect to one of our databases. The important thing is, this is what we do with the document. So here's that DB session. I just call a new element on it. Here's my document. That's the name of that class I mentioned earlier, and it's returned as an O element. From there, on this my document, I can call set property, just like before, name bill, set property age 42. But look at our graph example. Here's a vertex. I can call DB new vertex instead of new element, specifying the class, and it's returned as an O vertex. And I can call set property on it and set property. You know what else I can do? I can change O vertex to an O element and do exactly the same thing, because O vertex derives from O element, because we're multi-model. We support all kinds of ways of accessing the data, but in the same way. So, two different examples. This is using the Java API or the SQL example. Any questions?
So these two are basically interchangeable. So all the kind of data goes to the same place, and then so you can bring the data from even kind of like like path or like a graph data path, but it goes to the same place.
It's stored in the same location. Under the hood, how we store vertices and edges, or edges that connect to vertices, we use what's called a RID bag, which is multiple record identifiers. But they're really just links, and it supports millions and billions of those in an efficient way. But under the hood, it's still using the same record format with links to other documents. So everything that I do in graph, I can actually do in our document interface under the hood, and I often do that myself. If I don't want the complexity or even to think of it as a graph, but I still want to be able to link to multiple documents, then I use that. I can still use this link set or link bag or single link, all kinds of ways of getting there. But it's fast, it's efficient. The cool thing is you can use our SQL to still query or traverse even documents if they're linked together. So getting a little off topic, but it's really fun.
Two questions. I'll dig deeper into the memory management. Or does that?
Let's do it after, because I'm running really late. But
And then also replication, eventual consistency. How does
Sure.
it do that aspect?
I'll be happy to talk all you want as soon as we're done. I'm just running over. Is anyone here interested in doing the hackathon we came up with? We have pretty good prizes if you want, but we have instructions out front. But if you're interested, the rules are simple. I'm not saying the implementation is simple, but All we want you to do is import part of a blockchain, we'll leave it up to you how much, into an OrientDB database, making use of at least 2 of its multi-model capabilities. And I'll completely leave that up to you to decide if you understand it. Whatever client you want to use is fine. What we want to see is your implementation, so source code, and then a compressed database with that in it. And you can send it to inquiries@orientdb.com. And you have to do it by Monday. And we'll judge it, on Tuesday. And then let everyone know who won. And I believe I think there's actually just one prize, is $500. Is that right? So, I'm sorry? Cash prize. Yes, cash prize. So, actually, we're going to give it in Bitcoin. No, we're not.